Hello again. This is Ms. Nakayama. This is 1.3a, more on functions and their graphs. So again, being able to read that picture, there's a lot of information. So we're going to go ahead and get started. What we're going to be doing in this video is knowing how to identify intervals on which that function increases, decreases, or remains constant. We're going to use graphs to locate the relative maximum or minimum of a graph. We're going to test for symmetry, and then we're going to identify even or odd functions. And good for y'all. I know y'all did all this last year, so hopefully this will be pretty easy. Now, part of my job is to expose you to the math language. So don't be scared off by all these words. Okay, I'm going to try to help you decipher them and know what they mean. But first off, a function is increasing on an interval if f of x sub 1 is less than f of x sub 2. Well, f of x sub 1, those are the y values. Okay, so what this is saying is that and then it says whenever x sub 1 is less than x sub 2. So whenever we go from left to right on a graph, if my graph is going up, that's what the math says. Okay, then it's decreasing if that f of x, if the first y value is bigger than the second y value when we go from left to right. In this case, the graph would be going down. And then it would be constant if those y values are the same as we read our graph from left to right. In that case, our graph would be the same as you go across it. Okay, so our first example looks like this. State the intervals in which the given function is increasing, decreasing, or constant. So I hope y'all can tell immediately by looking at this graph that it is never constant, because if it was constant, it would be a horizontal line. Okay, and the easiest way is to, again, start at the far left and just trace it with your finger. I am going up. That means it's increasing. I'm going down. It's decreasing. I'm going up. It's increasing. Okay, so if you look at that, I do have two intervals, but those dots, I'm looking for where it changes direction. Y'all called those turning points before. Okay, peaks or valleys, however you wish to think about them. Okay, but my first one, okay, there's an arrow on both ends. That means it goes on forever and ever. So the smallest x value. So these intervals that you give y'all are always along the x-axis, and all you're giving me is the x coordinate of every point. So I'm starting at negative infinity, and I'm going all the way to -1. And there is another interval, but I mean, you can keep going. Let's just go negative infinity to -1. Then I'm going down, and the x values are -1 to 1. So that's my decreasing interval. And then at 1, it picks back up and increases again forever and ever. So when we have more than one, we use the little U symbol, meaning union, and then we go from 1 to infinity. And when you're stating these intervals, y'all, they're always parentheses, because you're not increasing or decreasing at a specific point. So it's always parentheses. That's a nice thing. Okay, another definition. Again, got to expose you to the language. A function value, f of a, is considered a relative maximum if there is no f of a, there's no value of y any bigger than that. So this is a y value, and this says it's a relative max if it's bigger than every other y value on that interval. Okay, in the same fashion, f of b is a relative min if it's going to be smaller than any other y value on that interval. Okay, look at this, our graph. So we're looking for, as I kind of mentioned to you before, we are looking for the peaks and the valleys. Okay, so a relative maximum is going to be that relative highest point. Okay, it's relative because this graph goes on forever and ever, so there is no absolute max. So in this case, our relative maximum is at the x value, that's what it says, of -1. And it has a relative minimum, a valley. So this is a peak, this is a valley, and it's a relative because there is no absolute. It goes on forever and ever. But the x value where that happens is at 1. So it has a relative min at 1. Okay, again, y'all did this last year, even and odd functions. An even function is that for which f of negative x equals f of x. And that means our graph is going to be symmetric to the y-axis. So it's easy to tell when you're looking at a graph, not so easy when you're looking at an equation, but I'm going to talk to you about it. And then, of course, we have an odd function that says f of negative x equals negative f of x. And that one is going to be symmetric to the origin. Okay? So basically what you'll hear me say is an even function makes that negative go away. And the odd function makes the negative come outside. But that's what's happening. Let's look at this last example. Okay, identifying whether we have even or odd functions. So determine whether the function, I just want to go down just a tad here. Determine whether the function f of x, h of x equals x to the fifth plus 1 is even. If it's even, then the negative goes away. H of negative x equals h of x. Or odd, the negative comes outside, or neither. So what I'm going to start off with is figuring out what is h of negative x of that function. And we've talked about evaluating a function previously. I'm going to write what I see here. Every time I have a variable, I'm going to put parentheses. And what am I going to put inside the parentheses is negative x, because that's what I'm trying to evaluate. And when I simplify that, negative x to the fifth is, I can get rid of the parentheses, it's still going to be negative. So I'm trying to figure out, is this the same thing as that? Well, clearly it's not, because there's a negative sign out front. So is it the same? The answer is no. All right. And so I'm looking, like I said, is it the same as that thing over there? And it's not. Okay. So then I'm going to come over here and go, okay, well, what about negative h of x? And the reason I'm evaluating negative, I've already done h of negative x. Okay. So now I do negative h of x, which means that negative comes outside right here. So I'm putting this in. So h of negative x, but what does this equal? And this equals negative whatever my function is. In this case, it's x plus 5. And when you distribute that negative, you're going to have negative x to the fifth minus 1. So to find out if it's odd, I want to know if this is equal to that, because they want to know if h of negative x is equal to negative h of x. So I'm looking at this one and saying, is this the same? And it's not the same. Therefore, h of x is neither. Now, if that was challenging for you at all, then you need to come see me and I will show you how you can use your table feature on your graph to figure it out. But if you plug numbers in, y'all, you can look and see, what if I put in 2, I get 33. If I put in negative 2, do I get 33? The answer is no. Okay? And if I put in negative 2, I don't get negative 33. In that case, it would be odd. So that's another way of looking at it if you struggle with the algebra. But regardless, come see me if you're having any trouble with these. Again, you did all this last year. Hopefully it's a review, looking at those graphs and knowing them. Thank you so much for watching, and y'all have a great day.